In the last lesson, we discussed the product rule and the power rule to simplify exponents, exponential expressions. In today's lesson, we will see how to use the quotient rule to simplify expressions. Now, what does a quotient mean? A quotient is a quantity divided by another quantity. For example, 2 to the power of 5 divided by 2 to the power of 3 is a quotient. Alright, let's simplify this. 2 to the power of 5 is 2 multiplied by itself 5 times, and 2 to the power of 3 is 2 multiplied by itself 3 times. Can you simplify this? You notice the 2 on the denominator cancels with a 2 on the numerator. Another 2 on the denominator cancels on the numerator. And a third 2 again cancels with a 2 on the numerator. What are we left with? We have a 2 times 2 on the numerator and a 1 on the denominator. When all the factors are cancelled, we have a 1. So that will be 2 times 2. 2 times 2 divided by 1 is 2 times 2. Now, 2 times 2 is 2 raised to the power of 2. Okay, so looking at this, can you tell me what is going to be the quotient rule? If you look at this, 2 to the power of 5 divided by 2 to the power of 3 equal to 2 to the power of 2. How did we get this 2? Very simple. The power on the numerator minus the power on the denominator. In other words, the power on the numerator is 5 and the power on the denominator is 3. And 5 minus 3 equal to 2. Now, we can therefore write 2 to the power of 5 divided by 2 to the power of 3 equal to 2 to the power 5 minus 3, and that is 2 to the power of 2. Now, this leads us to the quotient rule for exponents. What do you think the quotient rule for exponents is going to be? Now, look at the general statement of the quotient rule. A raised to the power of m divided by a raised to the power of n equal to a to the power m minus n. Okay, we are now going to use this in simplifying exponential expressions. Alright, I told you in the last class that I will explain the meaning of power 0. Alright, let's try over here. What is the meaning of power 0? Use quotient rule to simplify 5 divided by 5. Now, you know that 5 divided by 5 is 1. Is that right? Now, let's use quotient rule to simplify this. 5 divided by 5 means 5 raised to the power of 1 divided by 5 raised to the power of 1. Is that right? Okay. Now, how do we simplify this? The bases are the same and the exponent on the numerator is 1. The exponent on the denominator is also 1. So, using the power rule, this must be equal to 5 raised to the power of 1 minus 1. And that is 5 raised to the power of 0. Now, if 5 divided by 5 is the same as 5 raised to the power of 0, what is the value of 5 raised to the power of 0? You know that 5 divided by 5 is 1. And therefore, 5 raised to the power of 0 should also be equal to 1. Now, what does that tell you? Any base raised to the power 0 is 1. 2 raised to the power 0 is 1. X raised to the power 0 is 1. the quantity a plus b raised to the power 0 is 1. Anything raised to the power 0 is 1. Okay? Now we will examine the meaning of a negative exponent. What is the meaning of a negative exponent? Alright, use quotient rule to write 1 over 5 using exponents. Alright, can you give me an exponent that can replace 1? Give me an exponent that can replace 1. Well, you know that any base raised to the power 0 is 1. So, I can write this 1 as 5 to the power 0. Why did I choose 5? Because the denominator is 5 to the power 1. So, 1 over 5 can be written as 5 raised to the power 0 divided by 5 raised to the power 1. Is it okay with you? Because 1 can be written as any base raised to the power 0. Because our denominator base is 5, let's write this one as 5 raised to the power 0. Okay, can you use the quotient rule and tell me what this is? 5 raised to the power 0 divided by 5 raised to the power 1 should be equal to 5 raised to the power of 0 minus 1. And 0 minus 1 is negative 1. Look at this. 1 over 5 is the same as 5 raised to the power of negative 1. So, what is the meaning of a negative power? If 5 raised to the power of negative 1 equal to 1 over 5, what is the meaning of a negative power? A negative power is the same as the reciprocal of the corresponding positive power. You see, 5 to the power of negative 2 is the same as 1 over 5 to the power of positive 2. A very important result. X to the power of negative 2 is the same as 1 over x to the power of 2. A negative exponent is the same as the reciprocal of the corresponding positive power. A to the power of negative m is the same as 1 over a to the power of positive m. Okay, let's now do a simplification. Use quotient rule to simplify 1 over 5 to the power of negative 3. Alright, we need to use quotient rule. That means I can replace 1 on the numerator by what? Tell me, what can I replace this 1 by? I can replace that 1 by 5 to the power of 0. So 1 over 5 to the power of negative 3 can be written as 5 to the power of 0 divided by 5 to the power of negative 3. Now, can you use quotient rule to simplify this? What is quotient rule? Keep reviewing this all the time. The quotient rule is a raised to the power of m divided by a raised to the power of n is the same as a raised to the power of m minus n. That is the quotient rule. Remember, quotient rule can be applied only if the bases are the same. And same with the product rule. The bases have to be the same. So a to the power of m divided by a to the power of n is a to the power of m minus n. So what is therefore 5 to the power of 0 divided by 5 to the power of negative 3? It will be 5 to the power of 0 minus negative 3. Is that right? Okay, let's write that. So that's equal to 5 to the power of 0 minus negative 3. You see? The numerator power minus the denominator power. The numerator power is 0 minus the denominator power is negative 3. Now tell me, use your understanding of real number properties. What is 0 minus negative 3? I hope you remember your double negative property. Subtracting a negative 3 is the same as adding a positive 3. So this will be 5 to the power 0 plus 3, which is 5 to the power of 3. Now, I want you to watch this and understand this concept very well. Look at this. 1 over 5 to the power of negative 3 is the same as 5 to the power of positive 3. That means if an exponent has a negative power, that negative power can be made positive if you move the exponent from the denominator to the numerator. Isn't this now on the numerator? Yes. So 1 over 5 to the power of negative 3 is the same as move 5. When you move the denominator to the numerator and change the negative to the positive, 1 over 5 raised to the power of negative 3 equal to 5 raised to the power of positive 3. This means that a negative power on the denominator becomes positive when taken to the numerator. A very important concept, and you need to learn that very well. Look at this. Can you write 1 over x to the power of negative 2 using positive exponents? This x to the power of negative 2 is on the denominator. If you move it to the numerator, its power, the sign of the power will become positive. So 1 over x to the power of negative 2 is x to the power of positive 2 over 1. A negative power when moved to a negative power on the denominator when moved to the numerator becomes a positive power. There you are. Now tell me what this is. 1 over x to the power of negative 5. Can you write this using positive power? 1 over x to the power of negative 5 is x to the power of positive 5. A negative power on the denominator can be taken to the numerator. It will become positive power. In the same way, I can use the same thing for the numerator. If there is a negative power sitting on the numerator, we can move it to the denominator. Its power will become positive. Okay. Now similarly, a negative power on the numerator becomes positive when taken to the denominator. So, what you need to now understand is that if there is a negative power on the numerator, you can move it to the denominator, its power will become positive. If you have a negative power on the denominator, you can move it to the numerator, its power will become positive. We will practice that in solving problems. Okay, in that case, can you rewrite this for me? What is a to the power of negative m divided by b to the power of negative n? Now here we have a negative power on the numerator. Now we can make the power positive by moving that to the denominator. So if you move a to the power of negative m to the denominator, it will become a to the power of positive m. And this b to the power of negative n, if you move to the numerator, it will become b to the power of positive n. Okay? Okay, one more time. This a to the power of negative m, move it to the denominator, it will become a to the power of positive n. And this b to the power of negative n, move it to the numerator, it will become b to the power of positive n. And so, look how amazingly the powers now become positive. A to the power of negative m divided by b to the power of negative n is the same as b to the power of positive n divided by a to the power of positive m. Alright, so a to the negative m taken to the denominator become a to the positive n, and b to the negative n taken to the numerator becomes b to the positive n. Therefore, a to the negative m, a to the power of negative m, divided by b to the power of negative n, equal to b to the power of n, all over a to the power of m. Okay, in that case, let's simplify this. What is a over b all to the power negative n? A over b all to the power of negative n. Now, this can be written giving this power to each of these. A over b all to the power of negative n is the same as a raised to the power of negative n divided by b raised to the power of negative n. Okay, can you now rewrite this by making the exponents positive? What do? Simply invert it and the exponents will become positive. So this is the same as b to the power of n over a to the power of n. Now, that can now be written as b over a. Since the exponents are the same, I can write it as b over a raised to the power of n. Can you look at this and see a pattern? Look at this. A over b raised to the power of negative n is the same as b over a raised to the power of positive n. Alright, let me ask you this then. What is 7 over 8 raised to the power of negative 3? Can you rewrite this 7 over 8 raised to the power of negative 3? If you understood this, a over b raised to the power of negative n is the same as b over a raised to the power of n. In fact, you have a fraction inside the parenthesis, but all you need to do is invert the fraction and make the exponent positive. So what is this? 7 over 8 raised to the power of negative 3 is the same as 8 over 7 raised to the power of positive 3. Again, another very, very important result. Okay. Now, 2 over 3 raised to the power of negative 2. What will that be? How do you make that exponent positive? 2 over 3 raised to the power of negative 2 is the same as 3 over 2 raised to the power of positive 2. And that is 3 raised to the power of 2 divided by 2 raised to the power of 2, which is 9 over 4. Alright, let's when you simplify an expression containing exponents, the final answer must contain positive exponents only. So if I give you an expression to simplify, do not give me an answer that contains a negative exponent. You must make the negative exponent positive. Now, how would you do that? If the negative exponent is on the numerator, take it down to the denominator, the exponent will become positive. If the negative exponent is on the denominator, take it to the numerator, the exponent will become positive. So, in your answer, the exponent must always be positive. Alright, let's simplify this. 3 raised to the power of 2 divided by 3 raised to the power of 5. Alright, what will you use to simplify this? Use the quotient rule. What is the quotient rule? The quotient rule is when the bases of the numerator and the denominator are the same, the result will be the same base raised to the power of the numerator power minus the denominator power. So 3 to the power of 2 divided by 3 to the power of 5 is the same as 3 raised to the power of 2 minus 5. There you are. And that is 3 to the power of negative 3. But you cannot have an answer that contains a negative exponent. Your answer must contain only positive exponent. Now, you know that 3 to the power of negative 3 is a numerator quantity. So to make it positive, what all you need to do is take it to the denominator. Or, you know that a negative exponent is the same as the reciprocal of the corresponding positive exponent. So what is this? This is the same as 1 over 3 to the power of 3. 3 to the power of negative 3. Take this from the numerator to the denominator. Now remember, 3 to the power of negative 3 is the same as 3 to the power of negative 3 divided by 1. Yes. So, this is on the numerator. Take this down to the denominator. It will become 3 to the power of positive 3. And of course the numerator is just 1. 3 to the power of negative 3 is the same as 1 over 3 to the power of 3. Now, we can simplify these steps as follows. I want you to watch this carefully. 3 to the power of 2 divided by 3 to the power of 5 can be simplified like this. Look at this. 1 over 3 to the power of 5 minus 2. In other words, the quotient rule can be adapted in such a way that our answer will be a positive exponent. Now, we started by saying that in the quotient rule, we always subtract the numerator exponent minus the denominator exponent. But if you follow that, sometimes the result will have a negative exponent. So, let's redefine the quotient rule. Now, when you subtract exponents, always subtract the smaller one from the bigger one. If you notice here, the bigger exponent is on the denominator. And therefore, if the bigger denominator is on the denominator, then the answer will stay on the denominator. You see? So 3 to the power of 2 divided by 3 to the power of 5. The bigger exponent is on the denominator. So when you simplify it, put 1 on the numerator and make the denominator 3 to the power of 5 minus 2. That means the exponent is now going to stay on the denominator. Watch this. That is 1 over 3 to the power of 3. Did you understand this? Alright, let me see if I can explain that one more time. Now, if I want to find 5 to the power of 5 over 5 to the power of 3. Now, in this case, the exponent on the numerator is greater than the exponent on the denominator. So, this will be done as usual. Will be 5 to the power of 5 minus 3, and that will be 5 to the power of 2. On the other hand, if you have, let's see, if you have 5 to the power of 2 divided by 5 to the power of 8, now you have the bigger exponent is on the denominator. Now that means the answer is going to stay on the denominator. Your numerator will be a 1 and the denominator will be 5 to the power of 8 minus 2. That is 1 over 5 to the power of 6. Now, if you understood what I'm talking, then every time you use the quotient rule, your answer will come out with a positive exponent. That will be a lot easier. Well, we will practice this as we go on. Practice these several times. Alright. Using this result, we can modify the quotient rule. I'm going to make that statement here one more time. In other words, a to the power of m over a to the power of n equal to a to the power of m minus n if the numerator power m is greater than n. On the other hand, if the denominator power n is greater than m, your answer will be 1 over a to the power n minus m. Do you understand that? Okay, now this is the new way to define the quotient rule. Now why do we want to do this? This will ensure that the exponent of the answer will be always positive. Okay, let's try a problem. 1/2 raised to the power -1. Well, there is something that we did earlier that can be used very easily in here. And that is, you remember we talked about this, that is a over b raised to the power of -n equal to b over a raised to the power of positive n. Well, we can apply that right away here. So 1 over 2 raised to the power of -1 is the same as 2 over 1 raised to the power of positive 1. That's equal to 2. A very simple way to do that. Alright, find the value of -1 over 2 raised to the power of -1. Well, we just did this. 1 over 2 raised to the power of -1. What's the answer we got? 2. So what do you think the answer for this will be? -2. Well, anyway, let's go through that steps one more time. -1 over 2 raised to the power of -1 is the same as the negative sign will remain, and 1 over 2 raised to the power of -1 is 2 over 1 raised to the power of positive 1, and that is -2. Another one. Find the value of x plus y to the power of 0. What principle will you use here? X plus y to the power of 0. Well, you know that any number raised to the power of 0 is 1. So y to the power of 0 is 1. So what does this become? It becomes x plus 1. Okay? Another one. Find the value of x plus y all raised to the power of 0. Anything raised to the power of 0 is 1. Here we have raised the whole quantity x plus y to the power 0. What is the value? It is 1. Okay, simplify the expression 1 over x to the power of negative 1. Alright, you should be able to do this now. A negative power on the denominator can be made a positive power by taking it to the numerator. Now remember, a negative power does not mean a negative number. This is not a negative number. A negative power, what is the meaning of a negative power? A negative power simply means it is a reciprocal. So this x to the power of negative 1, when it goes to the numerator, it becomes x to the power of positive 1. In a rational expression, a negative exponent on the denominator becomes positive when it is moved to the numerator. So 1 over x to the power of negative 1 is the same as x to the power of positive 1, which is now on the numerator. In other words, you can see the reciprocal of x to the power of negative 1 is x to the power of negative 1 is taken to the numerator, it becomes x to the power of positive 1. Simplify the expression. Alright, this is a good one. X to the power of negative 2, y to the power of positive 3 divided by x times y to the power negative 1. Well, the first thing to do here is rearrange them so that all exponents become positive. Now, what kind of rearrangement will you do? X to the power of negative 2 is on the numerator. Make the exponent positive by taking it down to the denominator. Similarly, y to the power of negative 1 on the denominator, if you move it to the numerator, it will become y to the power of positive 1. Okay, so this is the rearrangement you're going to do. X to the power of negative 2, bring it down to the denominator, it will become x to the power of positive 2. And y to the power of negative 1, take it to the numerator, it will become y to the power of positive 1. Now, once you do that, half the work is over. So, x to the power of negative 2 moves to the denominator, become x to the power of 2. And y to the power of negative 1 moves to the numerator to become y to the power of 1. And so, let's do this. Again, x to the power of negative 2 from the numerator has moved to the denominator, became x squared. And y to the power of negative 1 from the denominator moved to the numerator, became y to the power of 1. Now others will remain where they are. Now all the exponents have become positive. What do you do to simplify this? What kind of rule will you use? We have three rules now: product rule, the power rule, and the quotient rule. Alright, what rule will you use here to simplify y cubed multiplied by y? Use the product rule. So y cubed multiplied by y will be y to the power of 3 plus 1, 4. divided by x times x squared is, using the product rule, x to the power of 1 plus 2, that is x to the power of 3. Okay, let's move on to another one. Simplify. 5 to the power of negative 1 z divided by x to the power of negative 1 y to the power of negative 1. Again, we do the same thing. What do? 5 to the power of negative 1 will move from the numerator to the denominator, will become 5 to the power of positive 1. Then x to the power of negative 1 will be moved from the denominator to the numerator. It will become x to the power of positive 1. And y to the power of negative 1 will move from the denominator to the numerator to become y to the power of positive 1. In other words, x to the power of negative 1, y to the power of negative 1, these both will move to the numerator, will become x times y. There you are. So 5 to the power of negative 1 moved to the denominator. X to the power of negative 1 moved to the numerator, became x. Y to the power of negative 1 moved to the numerator to become y. And z is there. The answer is x, y, z divided by 5. Another one. Simplify the expression. X to the power of negative 4 times x to the power of positive 3. What will you do here? First of all, we can use the product rule. The bases are the same, therefore add the exponents. It is easier to use the product rule there first. That means x to the power of negative 4 times x to the power of 3 equal to x to the power of, add the exponents, negative 4 plus 3, and that's equal to x to the power of negative 1. But you cannot have the answer that has a negative power. How do you make this power positive? This is on the numerator. To make it positive, take it down to the denominator. So this is the same as 1 over x. X to the power of negative 1 is the same as 1 over x. 5 to the power of negative 1 is the same as 1 over 5, and so on. Okay, let's move on. Simplify the expression. X to the power of negative 9 divided by x to the power of 2. Well, what will you do here? Well, here you need to start by making the power negative 9 a positive 9. How would you do that? How would you make that exponent positive? The x to the power of negative 9 on the numerator is moved to the denominator. It becomes x to the power of positive 9. Now, when you move x to the power of negative 9 from the numerator to the denominator, what is left on the numerator? You must understand that x to the power of negative 9 means 1 times x to the power of negative 9. Any number has a 1 multiplied by it. So when x to the power of negative 9 moves to the denominator to become x to the power of positive 9, you have a 1 on the numerator. So this is the same as 1 over x to the power of 9 times x to the power of 2. And now you can simplify the denominator using the product rule. What is the product rule? When the bases are the same, the answer will be the same base raised to the power of 9 plus 2. So my denominator is x to the power of 9 plus 2, and that is equal to 1 over x to the power of 11. Another one. Simplify. 4 to the power of negative 5 divided by 4 to the power of negative 3. What will happen there? You see, 4 to the power of negative 5 divided by 4 to the power of negative 3 can be written as, look at this, 4 to the power of negative 5 from the numerator comes to the denominator to become 4 to the power of positive 5. And this 4 to the power of negative 3 from the denominator goes to the numerator, becomes 4 to the power of positive 3. And now, watch this again. The power on the denominator is greater. So apply the quotient rule on the denominator. The power on the numerator is less. That means this will be 1 over 4 to the power of 5 minus 3, and that is equal to 1 over 4 to the power of 2, which is 1 over 16. I hope you understood these various steps. A very important kind of simplification. Okay, shall we move on? Next one. Simplify the expression 5 raised to the power of negative 2 plus 4 raised to the power of negative 1. Now, if you want to write this, first of all, 5 raised to the power of negative 2 is 1 over 5 raised to the power of positive 2 plus 4 raised to the power of negative 1 is 1 over 4 raised to the power of positive 1. I hope that is okay. And now we have, this is 1 over 5 squared is 1 over 25 plus 1 over 4. You see, we are back with the old skill. I don't want you to forget the skill of adding fractions. You have now 2 fractions for adding. What will you do? What is the LCD of 25 and 4? The LCD, there is no common factor between 25 and 4. The LCD for 25 and 4 is 100. So, 100 is the common denominator. Alright, review the process of constructing the numerator. How? 100 is the common denominator. Divide that by the first denominator, 25. 100 divided by 25 is 4. And 4 multiplied by 1 is 4. Follow that up with the plus. 100 divided by 4 is 25. Multiply that 25 with this 1, that will be 25. So my answer now is 4 plus 25 is 29 divided by 100 is the answer. It's a beautiful problem, isn't it? Okay, another one. Simplify. X to the power of 2 all to the power of negative 3. Okay, what will be the rule we're going to use here? Which of the 3 rules can be used to simplify this? X to the power of 2 all to the power of negative 3. The power of a power. Use the power rule. That means multiply the powers using the power rule. X to the power of 2 all to the power of negative 3 is x to the power of 2 multiplied by negative 3, and that is x to the power of negative 6. Alright, can you write that using positive exponent? What is x to the power of negative 6? Is 1 over x to the power positive 6. Okay? Alright, let's go and do another one. Simplify the expression. Negative 7v to the power of 4, that's one quantity, multiplied by negative 3v to the power of negative 5. Well, the first thing to do is combine like terms. What are like terms? You see, the numbers are like numbers. So you can multiply the numbers, then v to the power of 4 and v to the power of negative 5, the bases are the same. They are like terms. So we write it like this. Negative 7v to the power of 4 times negative 3v to the power of negative 5 is, we first multiply the numbers. Negative 7 multiplied by negative 3, and then we multiply the bases that have v to the power of 4 times v to the power of negative 5. Okay, tell me, what is negative 7 multiplied by negative 3? A negative number multiplied by a negative number is positive 21. Alright, so now this will be positive 21. How will you simplify this? V to the power of 4 times v to the power of negative 5. Use the product rule. The bases are the same. That means you add the exponents. So what is this equal to? This is negative 7 times negative 3 is 21. And v to the power of 4 times v to the power of negative 5 is v to the power of 4 plus negative 5, which is 4 minus 5. And that is 21 v to the power of negative 1. Well, a negative power is unacceptable, which means you need to take the negative power and make it positive by taking it to the denominator. V to the power of negative 1 is 1 over v, and so, well, this 21 belongs to the numerator. That will stay there. So this will be equal to 21 divided by v. Now remember, 21 will not go anywhere. It is only the quantity that has the negative power. V to the power of negative 1 goes to the denominator, becomes v to the power of positive 1. So 21 v to the power of negative 1 is 21 divided by v. Another similar one. Simplify. 2x to the power of negative 3 y to the power of negative 4 multiplied by 6x to the power of negative 4 y to the power of 7. What will you do here? Combine like terms. Now look at the like terms. I can multiply 2 by 6. Then I can multiply the numbers that have bases x. X to the power of negative 3 with x to the power of negative 4. Then the bases with y. Okay, so that will be 2 multiplied by 6 times x to the power of negative 3 multiplied by x to the power of negative 4 multiplied by y to the power of negative 4 times y to the power of 7. Now, do I really need to put this parenthesis there? I don't need it actually. I have done it just for the sake of showing those like terms. You don't need those parentheses there actually. Now that will be 2 times 6 is 12. And look at this, x to the power of negative 3 multiplied by x to the power of negative 4. Use the product rule. The bases are the same. So that will be x to the power of, add the exponent. Negative 3 added to negative 4 is negative 3 minus 4. And y to the power of negative 4 times y to the power of 7 is y to the power of negative 4 plus 7. Add the exponent. And what's that equal to? That will be 12x to the power negative 3 minus 4 is negative 7. And y to the power of negative 4 plus 7. What is negative 4 plus 7? Is positive 3. Okay, what is our next step? We need to deal with this x to the power of negative 7. We cannot have a negative power. So what do? Take this to the denominator so that the exponent will become positive. Make the exponent positive by moving x to the power of negative 7 to the denominator. So that will be 12y cubed will stay on the numerator, and x to the power of negative 7 will go to the denominator to become x to the power of positive 7. Okay? Practice this on your own. These are very important skills. Another one. Simplify the expression 6x to the power of negative 2, y to the power of 3, z to the power of negative 2 over 9x cubed y to the power of 2. Okay, first of all, if you notice, there is a 6 on the numerator and 9 on the denominator. We can simplify it. We can divide 6 and 9 both by 3. 9 divided by 3 is 3, and 6 divided by 3 is 2. Do you see how I simplified that? Okay, now therefore, this will now be, I have a 2, so 6 divided by 9 became 2 divided by 3. And this x to the power of negative 2 from the numerator came down to the denominator. Look at this. It became x to the power of positive 2. So this x to the power of positive 2 on the denominator is actually this x to the negative 2 moving from the numerator to the denominator. Similarly, z to the power of negative 2 from the numerator moved to the denominator became z to the power of positive 2. Now what is now left on the numerator? On the numerator you are left with a 2y cubed, and on the denominator you have this 3x cubed, and this x squared is this coming down to the denominator. Y squared is already there, and z to the negative 2, that is coming from the numerator to the denominator to make its power positive. Alright, what do you do now to simplify this? If you noticed on the denominator, x cubed times x squared can be simplified. I did 2 steps actually there. I used a product rule for x cubed times x squared. It became x to the power of 3 plus 2. And then I used, watch this, y to the power of 3 divided by y squared. You see, I used the quotient rule there. How? It will be y to the power 3 minus 2. So one more time, I did 2 things in that particular step. And what are they? I simplified x cubed times x squared as x to the power of 3 plus 2. And then what I did is I simplified this quantity. What's this? Y cubed divided by y squared. Y cubed divided by y squared. The power on the numerator is greater. So y cubed divided by y squared is y to the power of 3 minus 2 on the numerator, because the power on the numerator is greater. Okay. Now, what is that equal to? That will be 2 times y to the power of 1, 3 minus 2 is 1, over 3 times x to the power of 5, z to the power of 2. And that's simply 2y divided by 3x to the power of 5, z squared. A very, very important type of problem. If I were you, I will do this couple more times to make sure I understand each step. Okay, let's try another one. Simplify negative x raised to the power of negative 2. Now, you see the base is negative x. The power is negative 2. If you want to make the power positive, you take it to the denominator. So change the negative power to the positive power. Remember, we are not aiming to change this negative sign. We cannot change that negative sign. We can only change the sign of the power by moving it to the denominator. So negative x raised to the power of negative 2 is 1 over negative x raised to the power of positive 2. You see that? The base remains the same. Negative x will remain negative x. That negative will not become positive. Only the sign of the power will become positive. Now tell me, what is negative x raised to the power of 2? When a negative number is raised to an even power, it becomes positive. So that is 1 over x squared. Okay, another one, simplify the expression. Negative 3 times x to the power of negative 3 to the power of 2. Okay, first of all, this is the power rule. X to the power of negative 3 raised to the power of 2. What will happen? The powers will multiply. Use the not the product rule. You see, what's the rule we use here? The power rule. We use the power rule. X to the power of negative 3 raised to the power of 2 is, this negative 3 remains the same, is negative 3 times x to the power of negative 3 times 2 is negative 6. Alright, something that very often students confuse. You see, it is the negative power that we aim to make positive. This negative, you cannot make it positive. So this negative 3 is going to remain where it is. Where does it belong to? It's on the numerator. This negative 3 is on the numerator. X to the negative 6 now has to move from the numerator to the denominator so that the power will now become positive. Alright? So make the exponent positive. So only x to the negative 6 will move to the denominator so that the negative 6 will become positive 6. The negative 3 will stay on the numerator. So that will be negative 3 divided by x to the power of 6. And this negative will make the whole answer negative. So that is negative 3 over x to the power of 6. Okay, let's do another one. Simplify the expression 4x squared y cubed all raised to the power negative 3. What is the first step in simplifying this expression? Well, obviously the first step is apply this power negative 3 to each of these quantities. 4 raised to the power of negative 3, x squared raised to the power of negative 3, y to the power of 3 raised to the power of negative 3. And what does that become? It is 4 raised to the power of negative 3, there you are, x squared raised to the power of negative 3, y cubed raised to the power of negative 3. what is the next step? In these two quantities, apply the power rule. This is where the powers get multiplied. So that will be 4 to the power of negative 3, x to the power of 2 multiplied by negative 3 is negative 6. And y to the power of 3 raised to the power of negative 3 is y to the power of 3 times negative 3 is negative 9. You have three quantities, they all have their powers negative. That means they are all going to go down to the denominator so that the powers become positive. Now that means what will be on the numerator? The numerator will be a 1. So make the powers positive. That will be 1 over 4 to the negative 3 goes to the denominator, become 4 to the power of 3. X to the negative 6 goes to the denominator to become x to the power of positive 6. And y to the power of negative 9 goes to the denominator to become y to the power of positive 9. And finally, you can write 4 to the power of 3. You know what that value is. 4 to the power of 3 is 64. So the answer is 1 over 64 x to the power of 6 y to the power of 9. Okay? Another one. Simplify 5 times x to the power of 2 y to the power of negative 1 all to the power of negative 4. Now remember the negative 4, the power negative 4 is only for the quantities inside the parenthesis. It doesn't include 5. So the power of 5 is a 1. Alright, what's the first step? Apply the power negative 4 to each of these terms. And that will be 5 times x to the power of 2 raised to the power of negative 4. Y to the power of negative 1 raised to the power of negative 4. Alright, and that will be, we now use the power rule in these two cases. X to the power of 2 raised to the power of negative 4 will be x to the power of 2 multiplied by negative 4 is negative 8. So this quantity is now x to the power of negative 8. How about this? Y to the power of negative 1 raised to the power of negative 4. Both powers are negative. When you multiply those two negative powers, you get a positive power. So that is y to the power negative 1 multiplied by negative 4, that is positive 4. Well, there is only one more thing to do here, and what is that? X to the power of negative 8 will move from the numerator to the denominator to become x to the power of positive 8. So that will be 5y to the power of 4 divided by x to the power of 8 is the answer. Okay, another one. Simplify the expression. 3m to the power of 5 n to the power of 6 over 6m to the power of 4 n to the power of 7, all raised to the power of 3. Now in this case, rather than applying the power 3 to each one of these terms, it is better to simplify inside the parenthesis. Make it simpler, and then we apply the power to each. Now how do we simplify that? Now watch me do this. The 3 on the denominator, on the numerator, will go 2 times in 6. So the 3 on the numerator cancels with the 6 on the denominator, leaving it 2. And now watch this. M to the power of 5 on the numerator, m to the power of 4 on the denominator. How will you simplify that? use the quotient rule. That will be m to the power of 5 minus 4. Alright? So that will be m to the power of 5 divided by m to the power of 4 is m to the power of 5 minus 4. I wrote that on the numerator because the numerator power is greater. So it is m to the power of 5 minus 4. But now what's the powers of n? N to the power of 6 on the numerator, n to the power of 7 on the denominator. The denominator power is greater. So it is now going to become, it's going to stay on the denominator because the denominator power is greater. And what does it become? It becomes n to the power of 7 minus 6 on the denominator. I hope you understand this. The number is simplified to give you a 2 on the denominator. And m to the power of 5 divided by m to the power of 4, that gets simplified on the numerator as m to the power of 5 minus 4. And then n to the power of 6 divided by n to the power of 7 gets simplified and stays on the denominator. Why? Because the power on the denominator is greater. That is n to the power of 7 minus 6. Alright, what is that now? M to the power of 5 minus 4 is m to the power of 1, divided by 2n. 7 minus 6 is 1, the power is 1. You see, now the quantity inside the parentheses is very simple. We can now apply the power 3 to each one of these. And what will that become? That will be m to the power of 3 divided by 2 to the power of 3 times n to the power of 3. And the only one thing left is simplify that 2 to the power of 3. That will be m cube divided by 8n cube is the answer. Now, it is good to do this one more time to see how I simplified inside the parenthesis. Alright? Now, learn those skills. It's very important. One more. I hope you can read this. Simplify the expression. Now, what is the expression inside the parenthesis? X squared y to the power of negative 3 z to the power of 4 divided by x to the power of negative 1 y squared z to the power of 3 all to the power of negative 1. Now, first of all, let's make the negative powers inside the parenthesis, make the negative powers positive. How? Y to the power of negative 3 will come down to the denominator to become y to the power of positive 3. X to the power of negative 1 will move to the numerator to become x to the power of positive 1. So let's simplify the quantity inside the parenthesis. And that will be, what I have done is, the x to the power of negative 1 moved to the numerator to become x to the power of positive 1. And y to the power of negative 3 moved to the denominator to become y to the power of positive 3. That's the only thing I did there now. Now, you can now apply the product rule to simplify quantities inside the parenthesis. Is that right? X to the power of 2 multiplied by x to the power of 1 is x to the power of 2 plus 1. And on the denominator, y to the power of 2 times y to the power of 3 is y to the power of 2 plus 3. Let's do that. So that will be x to the power of 2 times x to the power of 1. This becomes x to the power of 2 plus 1. And on the denominator, y to the power of 2 times y to the power of 3 is y to the power of 2 plus 3. And I did one more. I did this, z to the power of 4 divided by z to the power of 3. What did I do there? I used the quotient rule. The power on the numerator is greater than the power on the denominator. So it is going to stay on the numerator as z to the power 4 minus 3. You understand that? Is that right? The power on the numerator is greater, so it is going to stay on the numerator, and the power will be 4 minus 3. Okay, now one more step there. X to the power of 3, z to the power of 1 over y to the power of 5. Well, now we can apply the power negative 1. So far, we kept that power negative 1 as it is. Now we can apply this power negative 1 to each of the term. What does that become? It is, well, you know that, well, let me see whether you recognize this. Right, you know that a over b raised to the power of negative 1 is the same as b over a raised to the power of positive 1. You see, we don't need to apply the negative power to all these. We can say, x cubed z to the power of 1 divided by y to the power of 5 raised to the power of negative 1 is the same as, simply invert and then make the power positive. It's the same as y to the power of 5 divided by x cubed z raised to the power of 1. Does it make sense? Yes? Using this property. A over b raised to the power of negative 1 is the same as b over a raised to the power of positive 1. So this quantity inside the parenthesis raised to the power of negative 1 is the same as inverting that inside the parenthesis. Y to the power of 5 now becomes the numerator, and x cubed z the denominator. The power now becomes positive. Okay, let's now write the last step. Now that's equal to y to the power of 5 divided by x cubed z. Well, we actually spent a lot of time simplifying exponential expressions using the product rule, the power rule, and the quotient rule. Now this is an important part of this course. I want you to do all the homework and make sure that you learn these skills very well. Alright, in the next lesson we are going to apply this again. Alright, so I'm going to stop this lesson here now. Once again, let me ask you, please go and do all your homework. It is now time that you consolidate all these skills, and I'll see you for the next lesson a little while later.